Okay, so today we're going to go over systems of inequalities. We've done systems of equations, if you remember, when we would graph two lines on the same grid and then we would find their point of intersection. Well, this is system of inequalities, so the definition of that is we're going to be graphing two or more inequalities on the same grid. So if you can write that down right here on definition, two or more inequalities graphed on the same grid. Now, when graphing, all inequalities must be in slope-intercept form. So that's your y equals mx plus b, okay? If not, you cannot graph it. Now, when solving an inequality, you must flip the inequality sign when you multiply or divide by a negative number. So you must flip the inequality when you multiply or divide by a negative number. Now, technically, this is only going to occur when our inequality is originally in standard form, okay? So this is the only time you have to worry about, oh, I'm gonna have to flip the sign, and so on. Okay, so remember our little hint. We would always look here. If there's a negative number next to your y, then your sign is going to flip. So let's write that down. All right, so let's review right here. When do we shade below? Well, we shade below with the less than signs, okay? Your left hand makes the less than sign. So dash would be the one without the line at the bottom. Solid would be the one with the equal sign at the bottom. When do we shade above? Well, it's the symbol your right hand makes, so that is the greater than signs or the greater than and equal to signs for the solid lines. Now, what is the solution to a system of inequalities? Why are we gonna graph inequalities on the same grid? Well, because the solution is going to be found on the double shaded area. Okay, so what is a solution? It is an ordered pair, so an x and a y, that is found in the double shaded area. And it makes both inequalities true. Remember how you can plug in the x and y to see if you get a true statement? Well, this ordered pair has to work for both, okay? So it's an ordered pair found in the double shaded area that makes both inequalities true. So let's go ahead and practice with some that I have down here. Step 1, we're gonna graph each inequality using a dashed or a solid line. Step 2, we're gonna shade the appropriate side using two different colors so that we can distinguish each inequality. And then we're gonna try to find a solution, okay? Now, one recommendation I have is when you are graphing two inequalities, you gotta graph one inequality first, do your shading for that one, then do the other one. I have students that graph both inequalities and then do the shading at the end, and then it gets confusing as far as to where to shade, okay? So do one whole inequality completely. So number 1, it says y is greater than or equal to x plus 2. All right, so this is my y-intercept. So here's the 2, so I know they're talking about the solid line because of the line at the bottom. So they're talking about this solid line. Greater means my right hand, I'm gonna shade above. So remember how we do that? We stand here and we go up. So for that solid line, I'm gonna shade above. So this is where above is for this solid line. So the graph is already there for us. We didn't have to graph it. Okay, so obviously, the one that doesn't have the line at the bottom, that is the dashed one, and it says y is greater than negative x. and then plus 0. So here's my y-intercept, 0. It's got a negative slope, and it's dashed, so I know that this inequality goes with this graph right here. And greater. Let's find out where greater is. I'm going to stand on my y-intercept, make an arrow up. That's where greater is going to be. So I'm going to shade. So it's good to use 2 different colored highlighters, because then you're going to clearly see where the double shaded area landed. So it is right here in this little triangle looking section. So this is where all the solutions are found. Now, you might be like, no, you said solutions were in the shaded. Well, yeah, but this is only shaded blue. So that means that these are all the solutions for this one. It's only gonna work for this one. This is only shaded green, so that means it's only going to work for this one. It's the double colored one that's telling you that it's working for both. So if I want a solution, it's got to come from the double shaded. So what ordered pair could that be? Well, that could be -1, 3. That's a good example. It could also be 1, 1, 2, 3. It could be 1, 3. Why? Because it's landing on the double shaded. Since it's landing on the green, I know it works for the dash, and then it's landing right on the solid line, so I know it works for that one too. Okay, so 1, 3 as well. These are all examples of solutions. A non-solution, well, you got options now. You can pick it from here, because that means it only works for one of them. You can pick it from the white part, because that means it doesn't work for any of them. Or you can pick it from the other color, because it only works for the other inequality. So these are the non-solutions. Okay, let's practice another one. So all these, the graphs have already been done for us, so we're just identifying which inequality goes with who, and then we're doing the shading. So I see 1 dashed, 1 solid. So obviously the less than right here doesn't have the line at the bottom. I know that's the dashed. So less than, I go stand on my y-intercept and I make my arrow down. That is less than. So all of this gets shaded for that one. Okay, the solid line has a less than symbol too, so I go to the solid y-intercept right here and less down here. So my solutions are going to be right here in the double shaded. My non-solutions are going to be over here. So a good solution could be 0, 0, or 0, -3. And there's many more. Here we go. So on this one, now we're lucky that one has always been solid and one has always been a dashed, right? But sometimes they're both dashed or both solid, so you have to really know how to look for them, okay? So I would focus on the y-intercept. This is a +2, so then I know it's that one, okay? Now this is the greater than symbol, so greater means up. And then for the dash, it's a less than, so I go to the y-intercept, which is a 0, and I go down. This is the less than. So my solution is going to be found right here. So I'm going to pick -4, 0 as my solution. And one more example. The dashed is a less than, so I go here to the dashed, less than. Okay, I go to the solid and that's a greater than. So here's the y-intercept of the solid line. If I go up, it's going to be that area. So as you can see, the double shaded area right here, this is where I can pick all my solutions from. So I'm going to go ahead and pick the origin, 0, 0. Why is it a solution? Because it's on the blue, obviously. And then it's right on the solid line. So it's a solution. It works for both. If you want to be safe, then go ahead. 1, 2, 3, 4, 3. That's another one. Okay, if you want to land right on the double shaded. Okay.